This is the scope of our project and these are the contents of it. During our internship, we studied following topics which included C and C++ programming, IoT and embedded systems. In C programming, we studied keywords, basic data types, operators, conditional structures and looping concept, arrays, pointer functions, storage classes and header files. In C++, we studied some basic OOP concepts. We studied about IoT, introduction to IoT, introduction to embedded systems, and peripherals. These are the peripherals required for our project. Now, what is peripheral? Peripheral is an internal or external device that connects directly to the computer. These were required in our project. We have used LDR sensor, temperature system, serial tank. Now let's see what is IoT. IoT, Internet of Things, simply describes physical objects that contain embedded technology. This is the architecture of IoT. Now, what is embedded system? An embedded system is a combination of computer hardware and software designed for a specific function. This is the architecture of embedded system. These are the project requirements. Control garden lights on basis of sunlight intensity, temperature system control, water tank control. These are the components required for the project. In hardware, we have used Arduino Uno, ETH W5500, PSF8574, temperature sensor, LCD, LDR sensor and LED. In software, we have used Arduino IDE which is used for coding, PicSimLab used for simulation, Null Modem emulator to configure ports of serial remote tank, and Blink IoT app. It is a mobile app which controls the operations. Now Arduino Uno. Arduino Uno is an open source microcontroller board based on Atmega 328P. This is how it looks. ETH-W5500 is a Ethernet. It is a hardwired TCP/IP embedded Ethernet controller that provides internet connection to embedded system. Here is the Ethernet server. PCF8574. It is a silicon CMOS circuit. It is a 8-bit input-output expander. Temperature sensor. It is an electronic device that measures temperature. LCD. Liquid crystal display controller which displays alphanumeric and symbols. LDR sensor. It is light dependent resistor. And here is the picture of it. Now, here comes the implementation. These are the output screenshot. This is the first step when we load the hex file. Here is the LED on-off pictures. When LDR is high, LED is on. When LDR is low, LED is off. Here comes the cooler pictures when cooler is on and off. These are the heater pictures where heater is on and off. This is inlet valve when it is on, inlet valve when it is off, outlet valve when it is on, outlet valve when it is off. These are the mobile screenshots from Blink IoT app. This is the notification of heater temperature. This is when heater automatically turn off when temperature rises above 35. This is notification of water level. This is water tank. This is when water tank is full. Inlet valve will automatically turn off. Water volume level. And here comes the conclusion.
Now we will move towards the simulation of the project. This is the source code of our project. In this there are many header files for LDR, for cooler, water tank system and for temperature. In this we have written a code to control cooler, inlet and outlet valve of water tank system and temperature. These all are the header files for LDR, serial, tank, temperature system. Now these all are the spare parts for water tank system, garden light system and for temperature system. For controlling all the systems we have used Blink IoT app. Now we will first demonstrate the water tank system. For this system we need to select tools and to go to serial remote tank on Pixem Lab. Then we will select the serial port. So we have selected the COM6 and COM7 virtual pair. Because of this, Pixem Lab is connected to water tank virtually. Now when we click on inlet valve tab, water starts filling. Now we can see that the water tank is completely filled up now. Now I will turn on the outlet valve and water starts flowing outside through outlet valve. We can see the real-time volume of water tank on CLCD as well as on Blink IoT app. When water level reaches level of 2000, the inlet valve will starts automatically and inlet and outlet valve will be working simultaneously. When I turn off outlet valve, one then once a tank get full and we forget to switch off the inlet valve, then it will automatically turn off the inlet valve to avoid the wastage of water. So this is all about the water tank system.
So this is our LDR sensor as we discussed before, and this bar here it is simulating the brightness or darkness. Essential to lower its brightness is the sunlight outside. So now I click on this and I'll drag it upward. So as the sunlight decreases, here the brightness increases. We could see that the light, the first LED, which is used to represent the garden light, is brightening up successively. I'll increase it and the brightness also increases with it, with the darkness, and finally it is at its brightest point. Now I'll bring down the and I'll now simulate I have simulated for the day. Now for night it transitioning to day and we see that the brightness of the light is decreasing successively and switched off. So this is essential an application of pulse width modulation. As we discussed in the slides before, to go on the temperature system, for that I would need to display my mobile screen. So here is my mobile screen. I'll be switching on my Blink IoT app. Here I have used design it to show two types. The first type one is related to temperature system that and on other side it is the water system. I am the end user and need to switch on the cooler. I'll be checking on cooler button. So I just pressed on it and switched on and we could see that the fan is to rotating now. And you can also see that the cooler is switched on and the notification is also displayed on the CLCD. So now I will switch off the cooler and now it is off. We can see that the temperature is rising and once it is above the 35 degree we get the notification that the temperature is above 35 degree and the that is turning off the heater and corresponding notification is displayed on CLCD. Now I will switch on the cooler and the temperature drops to ambient temperature. So this was the temperature system. Now